Okay, in this video, I'm going to use these properties of a natural logarithmic function. For instance, the log of the difference of logs is a log of a quotient, or sum of logs is a log of a product, and so on, to solve an equation for an unknown x. So here's our equation. And we're going to use the fact, we want to use the fact that two numbers are equal if and only if their natural logarithms are equal, because natural log is a one-to-one function. In order to take advantage of that, we need to have a log of a single expression on both the left side and the right side. On the left side, we don't have that. So we need to use the properties of logs to combine these two logs into the log of a single expression. And then we can equate what we're taking the log of on both sides to solve for x. So on the left side, we have a difference of logs. So using this property, the difference of the log of logs is a log of a quotient. So I'm going to rewrite the left side as log of first expression, x squared minus 9x plus 14 over, we're taking a log of it in a second term, x minus 7, and that is equal to natural log of 6. So because the logs of these expressions, x squared minus 9x plus 14 over x minus 7, and 6, the logs of those are equal, then these expressions themselves must be equal. But before we go any further, let's simplify this fraction here by factoring x squared minus 9x plus 14. So we can find two numbers whose product is 14, but their sum is minus 9. So since the product is positive, the two numbers must be the same sign. They must both be negative. So two negative numbers that add up to minus 9 and multiply up to 14. That would be minus 2 and minus 7. So what we get is natural log of x minus 2, x minus 7, all over x minus 7 is still equal to natural log of 6. The x minus 7s will cancel out. So now we have natural log of x minus 2 is equal to natural log of 6. So two numbers are equal if and only if their natural logarithms are equal. Therefore, we can drop the logs. Equivalently, what we can do is take the exponential of both sides, and that would get rid of the logs. So we end up with x minus 2 is equal to 6. So now we can add 2 to both sides and get our final answer. X is equal to 8. Now, it's a good idea in general when solving these kinds of equations to take your solution, or sometimes you might get solutions, you might get more than one, and substitute them into the original equation, because it's possible that they might not all satisfy. So in this case, I have x equals 8, so I have 8 squared is 64, minus 9 times 8 is 72, plus 14. So 64 minus 72 is minus 8, plus 14 is equal to 6. So I have natural log of 6, and I plug in x equal to 8. And in this term, I have natural log of 8 minus 7. That's natural log of 1, which is 0. So this term goes away completely, and I end up with natural log of 6 equals natural log of 6. So I've confirmed that x equals 8 is a solution of